Hey, Plumber-Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of Mathematics for Plumbers and Pipefitters. My name is Thomas, and in this presentation we're going to look at Unit 11, which is about plastic pipe. Now, in previous units we talked about this transition of the use of pipe. Earlier on in plumbing we stuck with metals. We had cast iron and galvanized steel. They were used for drains and water lines. In time they replaced galvanized steel with copper as a water line and as drains. But then there was another transition as plastics were introduced, and we had plastic drainage and now plastic water lines, PEX lines, and different options in plastics. It is interesting to note that these transitions sometimes take time. For example, when they first introduced plastic pipe into the plumbing industry in Utah, there was this requirement that they still use cast iron pipe below ground, and then they could use plastic pipe in the walls and the ceilings and whatever above ground. This was because they didn't quite trust plastics yet. They weren't sure if it was something that they could trust long-term below ground. Well, plastics have proven that they're good for drainage below ground, and so they loosened that up. But it is interesting that it took a little bit of time before they would allow plastics below ground. Now, ironically, today in commercial plumbing, we do PVC pipe below ground and cast iron pipe above ground. And this is partly because cast iron pipe is quieter, so in a commercial building you want quiet pipe. But it's an interesting change from when we first had plastics coming into the market. Another interesting note here in Utah is that if you look in houses that were built back in the 1970s and 80s, you're going to find a lot of black ABS pipe. It's a plastic pipe. But interestingly, at the same time we were starting to use ABS plastic pipe, PVC was also being developed. And it was just a matter of which one could get to the market soonest, which was the most available. It was ABS, so people started using it and it really stuck. You didn't see very many homes or other buildings being plumbed with PVC drainage pipe. What do you see today? Do you see very much of ABS? Not likely. Most new construction is all PVC. It's very similar in how we assemble them. The fittings are about the same in the size and shape and everything. But the transition really came about 10 to 15 years ago when ABS became more expensive to purchase than PVC. Now, some plumbers were using PVC prior to that, but again, you go look at any buildings that were built between the 70s and the 90s, and you'll see a lot of ABS pipe, not very much of the PVC. So again, cost is what drives the change. And there were plumbers using ABS that just went right to PVC when it was the less expensive option to use. Now, of course, there's pros and cons to each, but ultimately it's going to be the price that drives what is used in the market. Similarly with water lines, we were using copper, and as the cost of copper went up and PEX became available, PEX became more and more used. And we still see plastic pipes replacing copper pipes in even commercial settings today. And again, it's the cost of these materials as we purchase those as plumbers, as we sell those to customers, that drives these changes in the materials that we use. So once again, be open to the different changes that will come, because you may see a different material 20 years from now. Now, in these presentations, of course, I'm going to discuss some of what is in the book, but I encourage you to read that. Read what's in the text. Make sure you understand what are in each of these units. But in Unit 11, It talks about plastics, and it talks about how there are similarities in plastic pipe and fittings to copper as well as to steel, and we'll look at some of those comparisons. But as it compares to copper, plastic can be bought in long, rigid sticks that are 20 feet long. You can also buy plastic pipe of different types in coils. So there's different ways that we can purchase those and transport those as well. Now there are many different types of plastics. If we talk about drainage, then you have ABS and PVC. But once you get into water or pressurized lines, you have quite a wide variety. Approved pipe types are listed in the code, so you'll have a whole table that says here's the different types of pipe that you can use for water lines. But in plastics, that would include PVC, CPVC, PEX, and a whole variety of PEXs, different types. And as you get into each of these different types of plastic pipe, then you also have different ways of connecting those together. Now in this unit, we're not going to get down to like how do you connect this type of plastic or that type of plastic, but the book does emphasize the fact that if you're going to use a particular type of plastic pipe, then you should know how to do it. And you should look into the manufacturer's requirements and their recommendations for assembling the pipe so that you do it right. Now when we're dealing with plastics, we're throwing around all these letters, these acronyms, but really most of these are an abbreviation of their chemical name because people don't want to say their chemical name. For example, PVC is polyvinyl chloride. You don't go to the supplier and say, I need a polyvinyl chloride 90. It's too much. So we abbreviate, we take the abbreviated version of the chemical name, and that's where a lot of these names come from. Okay, while we're looking at chemical names of plastic pipe, we have to look at this one. ABS has a special name, and I want you to try and say it. Ready? I'm going to put it on the screen. I want you to sound it out. Here it is. Are you sounding it out? Yeah. Acrylonitrile butadiene styrene, or something like that. No wonder we just call it ABS, right? Right. Interesting other note about ABS. It was used for quite a while, as mentioned, but ABS has a higher tensile strength than other types of plastics. That means it is pretty strong, but that makes it stronger and harder. Because of the rigidness of ABS, it makes it more prone to cracks. That decreases its lifespan, and that's also why we're not using it as much as we are PVC, because over the last decades we've seen that ABS will crack, and there are many drainage leaks in people's homes because of cracked ABS pipe. Fun fact. As I've mentioned, PVC pipe is good for drainage or water lines, but you need to be aware that when it's drainage and it's listed DWV on the pipe, usually that has the cellular core. It's a more hollow or foam core inside of the pipe wall. It makes it a little more lightweight. It's cheaper to produce, but it is not as strong. So you don't want to be using a DWV pipe for a pressure situation, meaning like you go put a PVC DWV in a sprinkler line, it may rupture, or for other applications. PVC pipe can also be used for pressurized situations. You can look right on the side and it'll tell you the maximum pressure that it can hold and at what temperature. But that's an important word to be aware of, temperature, because as the temperature of the water or whatever inside of the pipe increases, the wall strength of plastic pipe decreases. So if you take a regular PVC pipe and you install that into a house and use it for water lines, and then you're running hot water from the water heater through that PVC line, it is not rated to handle that hot water, and it could rupture and flood the house. And this is why they use CPVC. This is chlorinated polyvinyl chloride. It has an extra chlorination on the pipe, which gives it greater strength at higher temperatures. So when we're doing plastic pipe for water lines, CPVC is one of the options because it can be used for both cold and hot. PVC pipes are glued together, or they call that solvent weld. So you want to make sure that you have the right glue. For example, PVC and CPVC do have a different glue. They have a different chemical makeup. So we need something different to help adhere those pipes and fittings together. You want to make sure you're using the right stuff. Similarly, you don't want to be using ABS glue on PVC pipe. It's a totally different chemical. It's a different plastic. You have to stick with ABS glue for ABS pipe. All right, have a look in your book at the bottom of the first page in Unit 11, and you'll see this diagram of plastic pipes spelled out. This is typical PVC stuff. What we're looking at here is a 1 1/4 inch nominal pipe size. If you remember, nominal refers to measuring from the inside diameter, and it doesn't have to be like exactly 1 1/4 inch. And we see a variation because of the wall thickness in the inside diameter, but we look at like generally what is it closest to. All right, yeah, this is a 1 1/4 inch pipe. Look over these diameters. The outside diameter for a plastic 1 1/4 inch pipe is 1.660 inches. That's bigger than 1 1/2 inch. So what you don't want to do is be like, get your measuring tape, measure the outside diameter and be like, oh, it's more than 1 1/2 inches. This must be 1 1/2 inch pipe. It's not. And now, of course, you can look at the printed words on the side and read exactly what that pipe size is if you don't know. But the outside diameter is greater than 1 1/2 inches. So let's look at inside diameter on these. We have 3 different schedules. This is similar to when we looked at steel pipe. We have a schedule 40, which is 1.364 inches. And that gives you, your typical wall thickness for pipe. And really, schedule 40 is the most common out there. But if you need a little more structural strength, maybe this is an industrial or high pressure application, then you can go to a schedule 80, and the inside diameter is now 1.256. Then we go one level higher, schedule 120. This is going to be the big, hard, heavy duty stuff. We're looking at 1.204 for an inside diameter, and for each of these you see that creates a greater wall thickness. On the next page in the book, there is a table that corresponds to this diagram of this PVC pipes we just looked at. And if you look at that, we have across the top the different schedules: schedule 40 PVC, schedule 80 PVC, schedule 120 PVC. And then below those in the columns we have listed their pressure ratings. So we can see with schedule 40 PVC, the water pressure maximum is 160 psi. Water 2, now we're looking at temperature, right? 73.4 degrees Fahrenheit. So what that's saying is if your water is up to 73 degrees in temperature, the pipe can hold up to 160 psi. Now we're going to look at similar temperature readings all the way across these, but look what happens when we go to the schedule 80 PVC pipe. Now for a similar temperature, they've got a 72. I don't know if that's a typo in here. Yeah, probably just a typo in the book, but around 70 degrees of temperature at Fahrenheit. Now on schedule 80 we see 200 psi. We have a significant increase there. We go to the schedule 120, and at the same temperatures we get 315 psi. So again, you can see if you know you're dealing with higher pressure stuff, you can accommodate by increasing the wall thickness by a higher schedule, and you'll be able to handle that. Now, there's a note at the bottom of this. We mentioned this before. CPVC is to be considered for temperatures higher than 120 degrees. Typical temperatures coming from a water heater should be somewhere around 120 degrees. Side note, if as a plumber you set it any higher than that, you are at risk for scalding people, and you don't want that liability. So let them turn up their water heater, but in the meantime we have to put in the pipe that can hold that sort of heat, so we use CPVC. Let's have a look at the sample problem here in Unit 11. The sample problem says PVC pipe is rated at 62% of the strength at 100 degrees Fahrenheit compared to its strength at 73.4 degrees Fahrenheit. that's just making a statement, right? The fact that at 100 degrees, it's not going to be as strong, so they give this number 62% of its normal strength. So here's the question. What water pressure may be used at 100 degree Fahrenheit for Schedule 40 PVC pipe? So what we do is we take the typical pressure rating, which is 160 psi, that's at your 73 degrees, and we're going to times that by 0.62, that's going to be our 62%, and that gives us 99.2 psi at 100 degrees Fahrenheit. That gives us a maximum pressure that we can put into that pipe. This is an example of the fact that we have to be aware of the pressures we're putting into the pipe, the strength of the pipe itself, those walls, and the way that that strength is affected by temperature. As long as we're aware of that and installing what is required, we shouldn't have any problems. Now, for the most part, we don't have to do as much of that figuring. Generally on a building, that's going to be spec'd out for us. But if you're doing residential, that's where you get into the area where they don't tell you what kind of pipe to use. They don't get into the nitty-gritty details of what to install. They just say plumb the house, right? And you need to be aware that there are limits to pipe. All right, now it's time for you to do some exercises. There are 7 exercise questions at the end of Unit 11. They are multiple choice, but in some of these you're going to do a little calculating to find the wall thickness, as we have done in the past. There are some questions about which schedule you would use for certain applications, so you can find that in the reading. And the last couple questions ask about the outside diameter of a pipe. Now in the unit it tells us we can find that on data table 2 in the back. We've looked at data table 2 before, but you're going to be looking for the outside diameter of a steel and then a plastic pipe. Now here's a hint. Steel pipe and plastic pipe, like PVC, have the same outside diameter. Good luck on your exercises. I'll see you next time.